Okay, let me just do a short video talk about backtesting. So assume that this is working well. Backtesting for var. Okay, it's VAR backtesting. Okay, this is heavily tested in FRM level 2 used in banks. Regulators, mainly Federal Reserve, right, will want to let the banks have many choices of reporting their risk management procedure. One of them would be just report to them about the VAR, and then they need to have enough people, enough power in-house to do it. So that's why so you tell me like how much risk you can take, and then you hold enough capital to hedge against it, right? And then you need to tell me whether your reported VAR valued risk is actually realistic. Okay, so I like the definition here. Backtesting gives a realistic check on whether VAR forecasts are well calibrated. It's central to Basel Committee's groundbreaking decision to allow the internal VAR models. Basel Committee they provide guidance for bank regulations. Okay, and then they have some mainly internal model approach. Okay, some banks can choose internal model approach when they have enough power in-house. And then they have some zones, right? If you did a great job, and then green light. If you didn't do that good, but okay, you have yellow light, and then they have red light. So the Basel Committee's rules are not focused. I'm going to cover the basic ideas behind. Okay. So define backtesting. You can backtest the VAR model with relatively easy. Okay, when the VAR model is perfectly calibrated, the number of observations falling outside VAR should align with the confidence level. So what does that really mean? Okay, so certainly if you tell me, right, your VAR is 1%, okay, what does that mean? Only 1% of the chance it will happen, right? So if it happens too often or too many times, then maybe your VAR is not a good idea, right? So it should be fewer, right? At least aligned with the confidence level you give me. Okay, a good or accurate model will produce the number of expected expectations. For example, of 500 days, right? A good 95% VAR will produce around 5% times 500 days will be 25 exceptions. Over 100 days, a good 99% VAR is expected to produce only 1% times 101 exception. In summary, the number of loss observations that exceeds the VAR is called the number of existence or exceptions. For example, if the VAR model is perfectly calibrated, right, 95% daily VAR should be exceeded about 13 days per year. It's calculated this way because we assume 252 days per year, and then they use 250 just to make it easy to remember. Okay, that in the real FRM exam you need to use this number, but the results will be similar. 99% daily VAR should be exceeded about 8 days per 3 years. Okay, so that's how it works here. So remember, market risk. Okay, it's all daily basis. Daily. Okay, it is not annual. Credit risk is every year. Basel Committee says 10 days, but like a lot of calculation would be just daily, every day how much you can lose. So we verify the model by recording the failure rate, which is a proportion of times VAR is exceeding a given time. Okay, we use binomial distributed model to do the calculations. Okay, so we assume independently identically distributed random variables. Then you guys should be familiar with this from high school. I will show you guys how to calculate it using an Excel example. So we are going to illustrate using Jorian's example. This is a book that is assigned by FRM exam, and then so this is a really good book, but for my class you don't have to buy it. If you are interested, you can get it. Okay. So we are backtesting a model with a 1 year, which is 252. We use 250 here in trading days, the bank employed 99% confidence interval with a probability of 1%, right? So because each daily outcome either exceeds the var or did not, right, the historical window of observation is categorized by a binomial distribution. If it exceeds, right, can you record it as 1? If not exceed 0, what does that really mean? Okay, so you tell me var is, let's say, $10 million, right? So you tell me the daily value at risk is $10 million or negative, you lose that much, right? You either lose, let's say, 20 million, and then there will be a 1, right? That means you lose, happens, right? It's an event. Or if you lose, let's say, only 5 million, right? It'll be a 0, okay? Or you gain 5 million. It's also 0, right? It's either 1 or 0, okay? So it's only 2 outcomes. That's why it's called a binomial distribution. This distribution is very useful in analysis, okay? Because there are a lot of things in our life can be either happening or not happening, right? Some will either get an A or not get an A. Some will either pass my exam or fail the exam, right? Or not pass the exam. So there's only 2 outcomes, no third one. So we use binomial distribution. So what does that really mean? Okay. So let me just, other than looking at this, I will just show you guys what it looks like using Excel and then clearly identify, okay? So I have an Excel pulled up. So let me just copy everything here and then start from something new, okay?
How's it going?
Okay, so that was professor visiting. Okay, we'll just continue with what we have here. You see the pen still works here, that's cool. But I don't know how to erase it. Okay, let me just clean it. Okay, so here's the deal, right? Here's the case we're gonna work on. Okay, I'll just use the mouse here to select. Okay, so this is good. Okay, so we see our previous example. Okay, let me just pull that up. Okay, so we are going to backtest, right? 250 trading days with a probability of 0.01. So if your var is 99%, what is the probability of happening? It will be 1%, right? It will be 1%. Okay, how many days should it happen? Okay, we have 1%. We have how many days? 250 days, right? So ideally, you should. It's very common, okay, to see that during the last trading year, there are 2 or 3 days, right? It happens. Certainly less the better. If it doesn't happen, it's good, right? If it happens, it means you lose more money. If you lose a lot of money, the regulator get really concerned. That's why they will want to let you know that maybe you need to make your requirement even more complicated. Okay, so let me just double check the video. Okay, a video just to make sure you get back. Okay, so if it never happens, what's the probability? Okay, if it never happens in the previous 250 days, what is the probability of that? So the probability it does not happen will be 99%, right? So there will be this. If it happens 1% of the time, 99% of the time it will not happen, right? How many days do we have? So we have 250, right? Essentially, you are going to do 0.9 times, right? How many of those do we have? 250. So that's why we're going to change it in a way that is. That's the probability, okay, during the last year, it will never happen on any given day. We have 8.001%, right? So what is the probability it will happen once in the previous year, okay? So if you understand how do we do a probability and combination distribution theory, so there are 250 days, right? So we are going to do, I will just write it here, given that I can. So your calculation should be C251, right? And then because we have 250 days, any day it can happen. So this will be equal to 250. So there are 250 combinations basically that it can happen, right? For example, those are the days, right? 1, 250. It can happen this day, it can happen on the second day, it can happen like somewhere in the middle, it can happen on the last day, right? So there are 250 possible combinations that can happen. And then for it to happen, right? So 249 days, you have not happen, right? And then 1 day happens, right? So for the 249 days, it will not happen, will be 0.99, right? To the power of 249 times the probability happens, right? 1 time. Okay, so that's that. And then 250 times that. Is that making sense? Let me just use the mouse here and to show that to you. So we will just do 250 times 0.99. Okay, probability of 0.49 times 0.01, probability of 1, right? So that's 20.47%. Is that making sense? So let me just erase it. Now I'm going to do another illustration here really quickly. Okay. So what if it happens 2 times? Okay. So again, right, you have 1 to 250 days, right? What are the combinations if it happens twice? So 248 times not happening or not meeting, right? You don't lose more than that, and 2 times happen, right? So there are you can those 2 days, right? 1, 2, and then others will not happen, or 1, 3, and then other days not happen, or 1, 4, and then you can 2, 3, 2, 4. There are a lot of combinations, right? In mathematics, you should learn that it should be 252, 2, right? So that equals 250 times 249 divided by 2, right? So that's how many times it should be. And then we are going to use this. It will be 99%, 248 times 1%, right, to the power of 2. So that's the probability of happening twice. So let me just erase all those, and then we're going to use Excel to show you how to do the calculations. Okay. So if you need to take some time, you can pause here and take a further look. So I'll just show you the combinations, right? In Excel, we can use 252 divided by 2, right? That's how many combinations we have, right? This certainly is not a percentage. We'll just use another number. And then there's a function in Excel called combine. Okay, combine. It will give you the same, right? 252, and then number select 2, right? So if you just format it this way, so it will give you the same, right? So we are going to just do combine. So this is a 250, right? And then we are going to do this, select this number, right? Times. So we have 99% here, fix it. So will be equal to 248, which equals 250 minus 2, right? I'm trying to get a formula here, times 1 minus, right? 1 minus, which is 1% of happening, right? To the power of this, right? So that's your calculation, okay? So you can just drag it, right? How many times it will happen? If you just plot it, insert. There should be a better way to plot it out. Okay, now you change the bins. Okay. Maybe I will just change this to category other than a number. With that, and change it. Yeah, I'm more familiar with analytical software other than this. Basically, this is what it looks like. Okay. You have 8.001% happen only 0 times. It will never happen. Yeah, you have 20.47%. It will happen once. 25. 0.74 times, it will happen twice, right? In backtesting, we care about how many times it happens less than a number, right? Just need to. So if you want to say, what is the probability it will happen less than 4 times? Okay, so less than 4 times, it should be the sum of all those, right? So you 75%, 75%, it should happen less than 4 times. If you go less than 5 times, then we can just move this up a little bit. So there are around 90% chance it will happen less than 5 times, right? If you change to less than 6 times, then this will be adding all those together, right? So there is 95%, 95.88% it will happen less than 6 times. Less than 7 times, we just move this one more cell down. So there is a 98.63% it will happen less than 7 times, okay? You can continue to drag this. So is that making sense? Okay, so you can continue to go down. So that's how you look at it. Certainly, we have I can just use Excel, right? Excel function, just like what I showed a while ago. And also we have something called a binomial. So the calculation we did here are binomial calculation. We just do it by hand, right? However, you can just do it using this function, okay? You can see that this is a binomial distribution function. Tell them we're gonna do it 250 times, and then if it happens 0 times, this is our probability of happening, and this is not cumulative. What is the probability? Okay, right. Certainly, this is called cumulative, right? Cumulative. And we have cumulative, right? You can just do you can just sum those, right? This is one way to do it, okay? Just like what I showed you, the probability of happening. So if you look at if you want to do 95% confidence interval in your backtesting, then if it happens less than 5 times, then you are 95% confident that this model is right, okay? Cumulative can be done in a different way, right? You can just change this. Okay, you can just change the last one to cumulative, and then that will give you this, which is it should be the same, okay, as compared with this. This is how you backtest it, okay? So it is quite common, okay? It is quite common. The bottom line is it's quite common to happen less than 4 times, okay? Is that making sense? However, if it happens more than 5 times, especially if it happens more than 7 times. Let me just mark this as green. So this is probably the green zone, right? This is probably the yellow zone. And then this is probably the red zone. Is that making sense? So that's how backtesting is. So that's all I have for today. Thank you all.